So now what we're going to be doing is converting between logarithmic form and exponential form. This is a stepping stone in order to know how to solve a logarithmic or an exponential equation. So we need to know how to convert between the two first. Now, like I was saying in the previous video, in order to get rid of an operation, you need to do the opposite operation. Well, we just learned the opposite operation to a logarithmic is exponential. These are opposite operations. So I'm looking here at number 1 and noticing, okay, there is a log. In order to get rid of that log, I need to perform the opposite operation, which is exponential, or exponentiate, it's actually called. Now, when I say exponentiate, that means take everything that is currently there and make it the exponent. Now, if log base 2 of 8 is our exponent, we need to have a base, right? A big bottom number. Now we keep the exact same base. Remember, log base 2 of 8, the base is 2. So I'm keeping that exact same base and making it my big base. So now log base 2 of 8, all of that is the exponent on 2. And whatever I do to one side, I must do to both sides. So I'm now going to put a big base of 2 on that right-hand side as well. So on the right-hand side, I have 2 raised to the power of 3. Now, because exponentiating is the opposite operation of log, when I have a base of 2 raised to the power of log base 2, those two cancel each other out. They are opposite operations. So they cancel out. And all that you're left with is that 8. So on the left-hand side, you're left with just 8. On the right-hand side, it just remains 2 to the power of 3. So I have successfully converted from logarithmic form to exponential form. Now I'll do this again because I know that that was kind of complex. I see in number 2, I'm trying to go from log to exponential. In order to get rid of that log, the opposite operation is exponential. So I need to exponentiate both sides, meaning I do the big base. I create the big base. So here, our base is 6. Log base 6 of 1/6. So I'm going to create a big base of 6 on both sides. So now log base 6 of 1/6 is the exponent, and also -1 is the exponent. And we know that when I have a base of 6 raised to log base 6, those are opposite operations, they cancel out. And you're left with just 1/6 on that left-hand side. Set equal to 6 raised to the -1 power. Now I would like to make a little side detour here and take a closer look at this exponential form. In Algebra 1, you guys were supposed to learn what are called exponent rules. And there's a few ones that you have to know. Whenever you have an exponent that is negative, in order to get rid of that negative, all that you have to do is take the base number and put it in the denominator with the positive version of the exponent. So here, that's just what they did. They took the 6 and put it in the denominator, and the exponent was -1. It now turns into a +1. But anything raised to the power of 1 is just itself, so that just becomes 6. Now let me try it again. Let's see here. 7 raised to the -2. In order to get rid of that negative, what you do is you take the base of 7, put it in the denominator, and now the exponent is the positive version. So we have 1 over 7 raised to positive 2. And 7 raised to the power of 2 is just 7 times 7, which is 49. Let's try it one more time. 8 raised to negative 3. You take the 8, put it in the denominator with the positive version of the exponent. So now this is 8 raised to the power of 3. 8 times 8 is 64, and 64 times another 8 is 512. So this is actually 1 over 512. So that's just a little side piece of information about exponents. Now let's keep going and do our last problem, number 3. This time we're going from exponential to logarithmic. Now it works the exact same way in that you're performing the opposite operation. So here we can see there's a number with an exponent. 5 raised to the power of 0 is equal to 1. In order to get this out of exponential form, you have to perform the opposite operation, which the opposite operation of exponential is log. So you have to log both sides. Now we keep the exact same base. So I take, let me erase this to create a little more room. Now what you do is you take log base 5 of both sides. So here, I'm going to make more room here so you can see exactly what I'm doing. So we took log base 5 of both the left and the right hand side. Now we know the opposite operation of exponential is log. So here I have log base 5 of 5. Guess what? That cancels out. And all that you're left with on this left hand side is 0. So we have 0 on the left hand side is equal to log base 5 of 1. So I've successfully converted from exponential back to log. Okay, so now that you have tried to convert from log to exponential form on your own, here are some explanations for the solutions you should have gotten. So first, we're trying to go from log to exponential. So here, taking a look at this first one, we know that the opposite operation of log, I have a log here, so the opposite operation is exponential, meaning you have to exponentiate both sides, or do the big base. So our base is 3, so I'm going to take a big base of 3 on both sides. So 3 raised to the power of log base 3 of 81, that 3 and log base 3 cancel each other out, leaving us with just 81 on the left-hand side. Set equal to, the right-hand side is 3 raised to the power of 4. And I'm done. I have converted from log to exponential. Now let's go the other way, exponential to log. I have an exponent here, so to get rid of that exponent, the opposite operation is to log both sides. So our base is 6. I'm going to take log base 6 of both sides. Log base 6 of 6 cancels out, leaving us with just 2 on that left-hand side. And on the right-hand side, it remains log base 6 of 36. And lastly, going from log to exponential, the opposite operation of a log is exponential. So we're going to exponentiate both sides. We're going to create that big base. So our base of this log is 2. So I'm going to big base 2 both sides. I'm just putting those parentheses there so you guys can clearly see that they are in the exponent. 2 raised to the power of log base 2 cancels. And you're left with just 1/8 on that left-hand side. And the right-hand side remains 2 raised to the negative 3 power.